Hey everyone, it's Justin again. In this video, we're going to start learning how to solve two-step equations. Then we'll complete 3 example problems. Before we talk about two-step equations, let's talk about presents. When you wrap a present for someone, you have to start by putting it in the box. You definitely don't want to wrap an empty box, but once the present is in the box, then you can wrap it in wrapping paper. And finally, I like to finish it off with a little bow on top. If I give that present to you, how would you unwrap it? Well, you'd have to undo all of these things, right? You'd have to take the present out of the box, unwrap the box, and take the bow off. But wait, hold on. You can't do that in that order. How are you supposed to take the present out of the box if it's still all wrapped up? You'd have to unwrap it in the reverse order from how I wrapped it. So take the bow off first so you can get to the paper, then unwrap the paper, and then finally, when you can get to the actual box, you could take the present out. Now, what do presents have to do with solving equations? Well, just like with a present, our goal is to unwrap the variable in an equation to get it all by itself. So when there's more than one thing happening to a variable in an equation, you're going to undo those operations in the reverse order. Everything else that you know about solving equations also still applies here, so we'll undo those operations with their inverses, and we'll keep the equation equal and balanced by always doing the same thing to both sides of the equation. Let's see what this looks like in action with a few example problems. The first example problem says to solve for b in the equation 19 equals negative 4b plus 7. Oh, hey, our variable is on the right side of the equation instead of the left. Actually, that doesn't really matter at all. We still want to get b by itself to find out what its value is. It just looks a little different, that's all. So just like with my one-step equations, I want to start by figuring out what is happening to b. Since I'm only concerned with what's happening to b, I can focus just on this right side of the equation. What things do you see here that are happening to b? Well, there's plus 7. What operation is happening with this negative 4? Yeah, coefficients are multiplying the variable. So b is being multiplied by negative 4 as well. But the order is very important. Think about the order of operations. What's happening to b first? The multiplication or the addition? Multiplication comes before addition in the order of operations, so if we order these steps, first b is being multiplied by negative 4, and then 7 is being added to that. How can I undo these operations with their inverses? Exactly. The inverse of multiplying by negative 4 is dividing by negative 4, and the inverse of adding 7 is subtracting 7. And here's the part that's new for two-step equations. Just like opening a present, we need to undo these in the reverse order. So I'll work from the bottom of my undo list up to the top. We'll start by undoing the addition first, so we need to subtract 7 from both sides of this equation. Pause the video now and do it yourself. On the right side, I'm going to combine my constants since they're like terms. Positive 7 minus 7 makes 0, and I don't have to write 0, so this is just negative 4b. On the left side, 19 minus 7 makes 12. Now, the only thing still happening to b is it's being multiplied by that negative 4. Pause the video here and try to finish solving this on your own. We can undo multiplying by negative 4 by dividing both sides of the equation by negative 4, since they're inverses. On the right side, negative 4 over negative 4 makes 1, so this simplifies to 1b. Since the 1 in 1b doesn't actually do anything, we can write this as just a plain old b. On the left side, 12 divided by negative 4 makes negative 3. So our solution is that b equals -3. If you like seeing your variable on the left side, you can absolutely rewrite this solution as b equals -3. Since both sides of the equation are equal, we can always write it in either direction. Remember, we can always substitute this solution back in for b in the original equation to check our work and make sure that it's correct. In this case, we can see that it is. Let's try another one. This example says to solve for w in the equation, w over 9 plus 2 equals 5. I bet you know exactly what I'm going to say. We should start this problem by figuring out what's happening to w and how we can undo it. Pause the video and do this now. Make sure to pay special attention to what order things are happening in and what order we can undo them in. Thinking about my order of operations, the first thing that is happening to w is it's being divided by 9. Then we are adding 2 to that. I need to undo those in the reverse order. So first I'm going to subtract 2 and then multiply by 9. Go ahead and pause again here to try solving this on your own. Working backwards, first you should subtract 2 from both sides. On the left, I need to make sure I combine that with the other constant since they're like terms. Positive 2 minus 2 makes 0, or we can say that these just cancel out, leaving just w over 9. On the right, 5 minus 2 makes 3. Next, I need to multiply both sides by 9. On the left, what's really happening here is that I'm multiplying the whole number 9, or 9 over 1, times the fraction w over 9, which makes 9w over 9. And then 9 over 9 cancels out, or simplifies to 1, so this is 1w, or just w. As you get more comfortable and experienced with solving equations, you may start to skip over some of these in-between steps that we're diving into. So we have w on the left all by itself now, which is exactly what we wanted. And on the right, 3 times 9 makes 27, which we should bring all the way down to our last line to see that our solution is w equals 27. For our last example problem, I'm going to have my friend Jenna go through it with you so that you can see how another person approaches solving two-step equations too.
Hey everyone, it's Jenna. Let's jump into this third example problem. This says to solve for w in the equation w plus 2 over 9 equals 5. Hey, wait a second. Doesn't this look similar to the last problem you did? We have w, adding 2, and dividing by 9, but it also looks different. Let me put them next to each other so I can see what's going on here. What's different about these? Oh, I see. In the last problem, only the w was being divided by 9. But in this problem, the w and the 2 are being divided by 9. So how does that change how I need to solve this equation? It doesn't change the operations. Does it change the order that those operations are happening in? I'm not super sure, so I'm just going to take this expression, w plus 2 over 9, and I'm going to substitute 7 for w just so I can get a feel for what order these operations are happening in. Okay, so if I substitute 7 here, what would I do to the 7 first? Well, since the 7 and the 2 are both in the numerator of this fraction, they're really being grouped together. So I would add 2 first. And then I would take that sum and divide it by 9. Okay, so if I take that back to the equation, w is first getting 2 added to it, and then that is being divided by 9. So I'm going to undo those in the reverse order, starting with multiplying by 9 on both sides to get rid of the denominator. I like to draw a line down the center of my equation at the equal sign so that it's easier for me to check visually that I've done the same thing on each side of this line. Now, I know that this 9 should cancel out with the denominator, but it never hurts to write out all the in-between work. So if I multiply straight across, this would become 9 times, well, this whole expression, all over 9. And then 9 over 9 cancels out and leaves just w plus 2. And over here on the right, 5 times 9 just makes 45. I'm going to bring that all the way down so I have a nice full equation to keep working with. Now I have to get rid of plus 2 by doing minus 2 on both sides. These will cancel and make 0, leaving me with just w on this side. On the other side, 45 minus 2 makes 43. So the solution to this equation is w equals 43, which is definitely very different from the solution to the last example problem. Cool. I'm going to hand you back over to Justin to finish up with this lesson. See you again soon.
Solving two-step equations is very similar to what you've already done with one-step equations. The only extra thing to do is determine the order in which things are happening to the variable so that you can undo them in the reverse order. Just like how you would have to unwrap a present in the reverse order that it was wrapped in. You can't take the gift out of the box if it's still wrapped. Now that you've finished up the lesson video, there's a bonus activity in your PDF about different methods of approaching the same equation. Then you'll head off to the practice game for this lesson. Good luck, and write out all of your work to make sure you stay organized and build yourself a strong foundation. I'll see you next time!